Are you sure about the fuel pressure on auxiliary?
Yes, sir. Ran a full diagnostic. She's ready to fly.
The summer of 1940, Royal Air Force Hornchurch Airfield, Essex. Two identical Supermarine Spitfires rest side by side on the concrete apron, each fitted with the same Merlin engine, armed with 8 guns, and piloted by the same man, Squadron Leader Desmond Cook. He powers up the first aircraft. Takeoff run, 320 yards. Climb to 20,000 feet, 11 minutes, 8 seconds. Service ceiling, 32,000 feet, where the air thins and engines strain for breath. 20 minutes later, Cook climbs into the second Spitfire. Same airframe, same engine, only one change: the propeller. Takeoff, 225 yards. Climb to 20,000 feet, 7 minutes, 42 seconds. Ceiling, 39,000 feet. The same plane, the same power, the same war. Yet the margin between triumph and defeat in the Battle of Britain rested on 3 aluminum blades. Across the Atlantic, many experts had dismissed this new propeller design as too complicated to ever succeed. But Frank Caldwell's revolutionary invention, the one that would soon allow U.S. bombers to fly 100 miles per hour faster, had just proven its worth over English skies. The story of how one determined engineer's calculations shattered an entire industry's skepticism began 8 years earlier in a noisy factory filled with doubt. In February 1932, Frank Walker Caldwell, a 43-year-old MIT-trained mechanical engineer, stood inside Hamilton Standard Propeller Corporation's test facility in East Hartford, Connecticut. With his wire-rimmed glasses and clipboard always in hand, he was a man who believed more in numbers than opinions. Before him spun a gleaming experimental propeller on a vibrating test stand, 3 aluminum blades capable of changing their pitch even while rotating at 2,400 revolutions per minute. 3 days earlier, a call from Boeing Field in Seattle had set this moment in motion. Boeing's new Model 247, America's most advanced airliner, was grounded in Denver. At a mile-high elevation, its twin wooden propellers, fixed at a single pitch, left it struggling to clear the Rockies. Pan American Airways President Juan Trippe issued an ultimatum: fix the problem, or he would switch to Douglas aircraft. United Airlines had already ordered 25 planes. TWA wanted 30, but none of that mattered if the aircraft couldn't climb high enough to complete its route. Caldwell had heard all the objections before. The consensus across America's aviation world was that variable pitch propellers were impractical, too heavy, too complex, too fragile. The Army Air Corps had even declared Caldwell's hydraulic mechanism mechanically unsound. Even Charles Lindbergh himself had questioned it during a meeting at Wright Field the autumn previous. But Caldwell, who had been right many times before, trusted his data. As the government's chief propeller engineer from 1917 to 1928, he had already seen the same resistance to metal blades and adjustable designs, only for his figures to eventually prove the skeptics wrong.